Hello, and welcome to Rhino Toolhouse virtual demo series. My name is Scott Janssen. I'm the product manager for material handling products at Rhino Toolhouse. Thanks for joining again today. We're going to talk about the new G-Force 2 product line. So I want to go back about 12 years when I was a manufacturing engineer just out of college. This is the first time when I came across the G-Force product line. And the first thought I had when I saw it and I saw the price, I said, man, that's a lot of money for a hoist. But now that I've been working with the product for the better part of 8 years, the problem with that initial assessment was I compared it to a hoist when it's so much more. That's why we call it an intelligent assist device. Now, human beings, we're incredible machines that can perform extraordinary tasks. However, over prolonged periods of time, that can lead to soft tissue damage, and you will not find a device on the market that's going to mimic the human body as well as the G-Force. Just one of the many benefits of the G-Force product line, and with the release of the G-Force 2, we just got smarter. So in this presentation, you will see that the investment easily meets the value of the product. With that, I'd like to introduce the foremost leading expert on intelligent assist devices. That is the product manager at Gorbel, is Mark Grandusky. Just a quick note, if you have questions, you can go to the bottom of your screen. You'll see a chat window. You can type them in there, and we'll address all your questions at the end of the video. So enjoy, and Mark, take it away. Let's stop sharing.
Description of the product. I am Mark Grandusky. I'm the product sales manager for the lifting device product line for Gorbel. I guess before we get started, I'd like to welcome you all here. This is a great collaborative event between Rhino Toolhouse and Gorbel, and we've had a great partnership with Rhino Toolhouse over the years, and this is a fantastic event to have. Kind of groundbreaking for us. It took a lot of work and effort to get the live streaming event from Milwaukee to New York and to your computer screen, so that worked out really well, and I'd like to thank everybody at Rhino Toolhouse for all the effort they put into that. So before we get started, I want to talk a little bit, before we get into the intelligent lifting device, the ILD, let's talk a little bit about what else is out there, right? So what are other devices, or what other main devices out there that people typically use in material handling? And really the workhorse of the material handling industry is the electric chain hoist. So Gorbel does have a line of electric chain hoists, and you can see up here, we've got a full line, single phase up to 1 ton, 3 phase up to 5 ton, single speed, dual speed, and everything in between. So we could offer that to you. And I always tell people that if you can do your application with an electric chain hoist for a couple $1,000s, that's absolutely the right thing to do. And Gorbel and your representative at Rhino Toolhouse can help you out with that. But there are applications where precision and speed, where the electric chain hoist or maybe other devices fall short. And as Scott indicated in his introduction, there's just a whole lot that the G-Force can step up and take care of with regards to speed and precision, smoothness, and intelligence features. So without further ado, let me get right into the kind of the demo. So the one thing you'll notice that's different about the G-Force or the intelligent lifting device is when you grab onto this handle, this is what we refer to as a slide handle. I simply engage the product and I move my arm. That's all I'm doing is I move my arm. I don't think about anything else. I'm not thinking about throttling up or throttling down. I'm not thinking about pushing a button. This literally marries with the motion of my body, and it takes a very little force to go up or down. There is an operator presence sensor on the back side of this handle, so if I try to move it inadvertently, it won't move. But I can grab onto this and literally just move my hand anywhere I want, as fast or as slow as I want, and it'll move with me. So that is the main difference. And you'll also notice the speed. The speed is much different than electric chain hoist. A typical electric chain hoist speed is about 16 feet a minute, maybe up to 32 feet a minute on a fast one. The G-Force in this capacity, which is 165 pounds, will go up to 200 feet a minute. So you have incredible speed, and then you also have this precision, so you can transition from fast to slow wherever you want. Now, that speed comes about because there's a very different kind of control system and motor in the intelligent lifting device than would be in a standard electric chain hoist. Electric chain hoist uses an induction motor. It's just simply a motor that you apply power to. It's going to spin as fast as it can until you take the button off. You reduce it with gear reduction, but it's a dumb motor. It doesn't know really what it's going on. It knows that you've applied power. It does what it does until you either overload it or you take your hand off the button or disengage power. Did you rewind a little bit, or did everything come through up to where I left off?
Everything was.
All right, I'll just pick up where I was then. So we're talking about the difference between the induction motor that's on a chain hoist and the servo motor control system that's on a G-force ILD. So a servo motor system is very tightly controlled. It's a type of control and motor system that would be in an arm robot, skater robots, anything like that, any kind of pre-programmed machinery. CNC high precision machining centers use servo motors. So that's what's going to get you that control and that precision that you'll never get out of an electric chain hoist or a non-servo based product. So the other thing that you've got with the G-force, besides the speed and the precision of what we call run mode. So when I've got my hand engaged on the product and it's moving with me, that's what we call run mode. There's another mode in here called float mode. So what I can do, and I've got really good precision as I showed you, but if I needed to put this piece of bar stock in this horizontal turning machine here, that's just chuck, it would be really good if I could actually put my hands on the product and guide it rather than having to do it from the handle and use two hands maybe. So I can do that with this product, and we'll go into a second control mode called float mode. When I press this button right here, you're going to see a blue light up right here. And now what that does is it puts it into a float mode. Now I can float this product, and I can float it throughout the entire stroke of the G-force range, which, by the way, full up to full down is about 11 feet standard. So you can go full up to full down, total travel is 11 feet. But now what this allows me to do is actually take and load this piece of bar stock into the chuck, okay? So I can put this right in there, and I guide it right in very easily, and I put it in. So now that would be, if you were to compare that with doing it with, if you could imagine doing that same operation with a chain hoist, what's going to happen is you're going to have the pennant in one hand, and you'll be jogging up, jogging down, trying to get that right position to get this into the chuck like I just did. If you over jog in the up position with the hoist, it's going to go up, and it's going to push upward with the force, the full force of the capacity of that chain hoist. What could happen there is you damage your product, you damage your equipment, right? If I was to over jog in the downward direction, the gravity takes over, and the weight of my part now is jamming that into the machine. The beautiful thing about float mode, besides the actual control that we have, is the fact that when I press on float mode, this is basically weightless, and there's no more weight ever that's going to be on this part or on your machine than you're pressing with your finger, right? So when I put that in, or if I put this on the table, there's no more force underneath here, and I could actually put my finger underneath there. There's no force on my hand other than what I'm pressing on with my finger. So that is a big thing for loading machine centers, any kind of assembly operation. That really works out really, really well. So what I'd like to show you, as long as we're talking about float mode, and Scott had mentioned we've just upgraded our control system. We've added this new feature where we have what we call the Smart Connect user interface. And this Smart Connect user interface is actually wirelessly connected. It could be a wire, but I've got a wireless line of sight connection that I can make to the G-force, and I can do all kinds of different settings. What I'm going to do here is I'm going to go over to my settings mode here, my settings menu, and under float mode on the screen here, you'll see there's a little tab here that says manual. I'm going to press that, and it's going to change to auto. What that does, if your process is such that you don't want to have your operator having to press the button to transition between run mode and float mode, this mode actually allows you to go back and forth seamlessly. So I can now grab this handle and run in run mode, and then without pressing a button, I can actually go right to float mode. There's just a slight difference you'll see from the time that I let off my hand off the handle. There's maybe a half to 1 second initiation process, but you'd get away from your operator having to actually press a button to do that. So that's an option. If you could use it that way, or you can use it in the manual mode like I showed you before. So I'll turn that back to manual for now. And I'll load this back in the chuck, go back into float mode here. Now what I'm going to do, I'm going to put this in the chuck, and I'm going to show you another thing. We're going to get into virtual limits here in a second. So if I were to go full up speed now, and I try to remove this part from the chuck, and I was to take it back out, say I went through a machining cycle, I needed to come in and grab it again. If I went full up, I could potentially maybe put too much force on there. So I can error proof these applications. What I'm going to do is come over here. I'm going to go to my virtual limits tab, and I'm going to enable what's called an upper slowdown. So I'm going to enable right there, and you'll see on this this page, there's a position of the current position of the G-force, and then I've actually set a position previous to starting this this demo. You'll see right here there's a positional numeric position here that is locked into where it says upper slowdown. What that does, it allows me, when I go in the upward direction, it's not going to go real fast. So I've got control. I'm not going to bind that. I'm not going to over jog or over when I'm trying to get that part back out. It's not going to bind on me. So I've got that slow down there. I can also set a hard stop upward or a hard stop downward. Or there's some other ones we'll see in 1 second when we pick up the triangle. So I wanted to point that out. So I'm going to go ahead and disconnect this. We're going to pick up our triangle. Let me turn off our upper limit again. So come back over here, disable the upper limit. So now I can actually go free, upward, and downward. I'm going to come over here. I'm going to pick up the triangle. And this is about, by the way, the weight of this load, the magnet and the bar stock is about 70 pounds. And this is about 45 to 55 pound triangle I've got on the load here, or on the G-force here. So, so we went through auto float. We went through the different virtual limits and everything. As long as we're talking about virtual limits, I did want to show you, we could do error proofing like we did with this upward slowdown here. I'm going to do error proofing in a downward direction, right? So when I've got this triangle attached here, if I were to go down, you can see we talked about before, I've got that real high speed, 200 feet a minute top speed. I can go as fast as I want to go. I can also have my operator has the ability to transition to a very slow speed and be able to go very quickly and then transition to a very slow speed and then set it down on the ground with an incredible amount of finesse and precision. However, there's also operator error, right? There's human error in the equation. So if somebody's not paying attention and they maybe don't slow down quickly enough, they could potentially have the option to impact the floor at a high rate of speed, potentially damaging our product here, right? So what I can do here is just like I did the upper slowdown over here, I can come over here and I'm going to enable a lower slowdown point. So what I've done, again, we've got that numeric position of the lower slowdown that I've locked in and set prior to the setup here, or the demo, and those positions are locked in, and you'll see that that position is now takes effect right there, about 6 or 7 inches above the floor. So now if I try to do what I did before and my operator isn't paying attention and they try to go to the floor at full speed, they no longer can because it slows down automatically to a very slow speed and doesn't allow them to do that. So there's some of the intelligence features that allow you to error-proof your process. So what's the benefit of that is reduction in product damage, rework, scrap. And when you're talking about some of the applications that we get involved in with the G-force, like aerospace machining, high-value parts like that, a return on investment based on product damage reduction or reduction in scrap is a very quick ROI typically with applications like that. All right, so what I'd like to do now is we did talk about the G-force, and this is one form factor of the intelligent lift device. So the G-forces will go up to 1,320 pounds in 4 different capacities. So we've got a 165-pound model, which you're seeing here today. We've got another one up from that is 330 pounds, one up from that that's 660 pounds, and the final one at 1,320 pounds. Every unit that every unit will lift from 0 all the way up to its full capacity. The G-force does go on a bridge crane, as you see above here, and it's going to give you a lot of coverage area. So you could a standard Gorbel workstation crane with the G-force is going to give you a lot of coverage area option. But ergonomically speaking, you will see that when I move this around, just like I'm with a hoist, I have to move the weight of the actuator up there, the weight of the hoist or the intelligent lift device itself, and I have to move the manage the inertia and the mass of the bridge. So we have another option, which is very popular, and that's the EasyArm. So over here, I'll bring over the EasyArm, and you'll see the EasyArm is actually what looks like what you see up here on the bridge, riding on the bridge. We actually now take that power unit we call the actuator, and we put that on the top of the mast of the EasyArm. Now this is an all-in-one product, so when you say EasyArm, you're referring to the entire package. That's the arm, the articulated arm, the mast, and the power unit, the actuator, and the handle all together. So, and you'll notice we talked about that mass and inertia of the bridge and the intelligent lifting device on the bridge. This, on the other hand, has none of that because you've got a very light articulated arm, very smooth running roller bearings, very, very easy to move. And this, you can see I've got a 50-pound load here, and there's no way I'm going to manage the mass or the mass of say a 20-foot bridge, which gives you great coverage. But if I need smaller coverage area, I can use this, and it definitely has the ergonomic edge with this product. So what would bump you out of using EasyArm is if you had more coverage area that you could manage with a 14-foot span, which is the maximum span of an EasyArm, or the capacity goes up to 660 pounds. We have one. Remember, we talked in the G-Force, we go up to 1,320 pounds, and in the EasyArm, we go up to 660 pounds. So that's what either coverage area or capacity could kind of disqualify the EasyArm in your application. But if you can use an EasyArm, ergonomically, it is very ergonomically friendly because of how easy it is to move. And you notice you only have one column that goes in the floor to install. So it's easy to install, quick and easy to install or relocate. It's just four or 6 bolts in the base plate, and you can install or move it around as you need, as you see fit. And we do have portable base plates as well, so that you could actually put it on, if the arm was short enough and it was a 165, you could actually put it on a portable base that would move around with a fork truck and plug it in different locations as you move it around the shop. So that's also an option. But that EasyArm is a very popular option for us. But again, you choose the EasyArm for the ergonomics, but it's got a limited coverage area and limited capacity up to 660 pounds. The G-Force will pick up from there large coverage areas up to whatever coverage area you have that your crane is covering, and it goes all the way up to 1,320 pounds. If you're looking for recommendations on which one to choose, your Rhino Toolhouse sales rep will be glad to come out, do an assessment of your application, try to work out the best solution for you, and not only recommend the right G-Force or EasyArm for you, but also recommend some of the other accessories that we might get involved in. So the other thing we need to specify or talk about when we're talking about the G-Force and EasyArm is another part of the solution, which is the end effector tooling. So end effector tooling is what gets a hold of the actual product. So a lot of times with a chain hoist, you're going to be using a sling or chains or some kind of rudimentary fixture. With the G-Force, typically there's more often you're using sort of a complex air-powered clamp or vacuum or magnetic device that quickly gets a hold of the product, quickly releases the product, so you can take advantage of all that speed and precision. So if you're following along at home and with your brochure, you can get this online if you want, if you don't have one handy. But you'll see on pages 15 and 16, you've got a really good gallery of different examples of end effector tooling. Now, Gorbel does not manufacture the end effector tooling. This is for to help you kind of visualize different applications, but Rhino Toolhouse can absolutely provide that part of the solution for you, and that's one of the values they bring to the equation, besides actually helping you specify the total solution. But what you'll notice on this page is there's different types of handles. We saw the inline slide handle with this demo, but we actually have 7 different configurations of handles. So if you look on page 8 of your brochure, there's each one is called out. So we have the inline slide handle first. That's one that we've talked about here. You've got a remote mounted slide handle if you want to put that on a tooling framework. You've got a pendant handle that has 2 infinitely variable up-down levers that you can use, just like you could the slide handle, but that's a pendant instead. That's a popular option for tooling, and you can do that either a suspended pendant, like similar to a hoist, or you could do a remote mount pendant, so you can put that pendant on the tooling. Or we have what we call a force sensing line of handles, the inline, the force sensing hub, or the remote mount force sensing handle for different variations on the slide handle or the force sensing handle, which the benefit of the force sensing handle, it allows you to have a longer handle and either grab high or low on the handle and initiate motion, so you can actually pick high or low and keep in an upright standing position without having to bend down. So that is a couple of things that we need to consider when we're applying. So EasyArm, G-Force, what type of handle, what type of tooling is going to be involved. And again, your Rhino Toolhouse sales rep will be able to guide you through that entire process. So let's talk a little bit about, we talked about our error proofing, our lower slowdown. What I'd like to talk to about now is the G360. So while we're on the tooling subject, you'll notice on the top of the handle, on this particular unit, we've got the option added here for the air hose. So you're going to notice there's 2 coils here. There's a black inner, this is an electrical cable right here. This is what we call the coil cord. That's got all your electrical signals that allow the system to lift up and down, which is all, the lifting again is all electric powered, all servo. servo-powered electric. This blue coil is an air hose. That air hose has nothing to do with the actual lifting up and down of the G-force, but we do provide this so that you could power some sort of end effector tooling, venturi vacuum, some sort of a cylinder clamp, inner diameter, outer diameter clamp, magnetic and pneumatically releasable magnet could be used as well. So, but then not only do we provide that, and the way this would work is you would festoon your air supply down your bridge, down your runway and down your bridge to the G-force. It would hook to the top. It would bring it cleanly down to this point right here. And now actually, you can actually spin continuously 360 degrees, no tangling or damaging of the coils as a result of continuously rotating. And that rotates all the electrical signals. And you can see I can actually lift up and down while that's rotating. So all those signals are cleanly brought through that swivel or this collector. But then you also have an air swivel. And that air supply will go from here down to here where you have to add this fitting here. But this would go down to your tooling, and you can also rotate your air power for your tooling as well as all the electrical signals. So again, uptime, maximum uptime is the benefit of this, and least amount of maintenance because you're not going to have to change coil cords or air hoses. And I'm sure anybody who's been on the plant floor and has seen other devices that have had coils of air hose around the chain or the wire rope of the lifting device that's not an intelligent lifting device from Gorbel, you probably have seen these coils out on the plant floor somewhere on some other device, tangled, twisted. You may have even had to replace them, and they may have resulted in some downtime. So we've noticed through customer feedback that is a very important feature. So, and then I guess we want to talk about too is applications. So we talked about all the features and applications, or the features of the G-force. And what we'd like to do is talk a little bit about applications. So I mentioned machining centers, so loading of machining centers, especially in aerospace machining. Those parts are very high dollar, whether it be the ingots or the castings going in. They're high dollar alloys. They've got multiple hours of machining through different processes. And every time you take them out of one machine and load them into another machine, they get more and more valuable. At any point in that process, or any application like that where the part becomes more and more valuable through the process, it becomes more and more critical to reduce the potential for product damage or scrap. So that's where the G-force really shines. Also on the user interface here, I did want to go through some of the inputs and the outputs, the configurations that we have here. So one of the things with the new Q2 and iQ2 model that we just rolled out, all units will have some ability to have inputs or outputs to interface with external systems. So it kind of gets into error proofing. We talked about process error proofing before, but we're going to talk a little bit about safety error proofing. So one of the things with the inputs and the outputs, I'm going to go over here to my IO configuration. And this unit that I happen to have right here is a Q2 handle, and you'll see on the side of this handle there's a connector that you would connect to with a cable, and then you would use that cable to attach to any switches or sensors or anything on your tooling that you would want to. And you could, this block up on the upper right hand side will show you your inputs and outputs for that handle. Now what I've actually got assigned in here is for that block right now is I've got an auto home assigned right now. I don't have anything hooked up, so I can't put there. So I'll just explain what this would do. If I activated input 1, I could set a predetermined point at which it would travel, and it would travel to that point and stop. So you could have kind of semi-autonomous motion, but it is in that mode similar to a cobot, because if it doesn't encounter any type of resistance, it does stop or shut down immediately. So auto home is a feature here. Multi-zone virtual limits is on my input number 2 that I set. If I were to activate that input, just like we showed our lower slowdown and our upper slowdown, I could have multiple different heights for my different virtual limit sets at different points. So if I want to have a different slowdown point at my pickup point than I wanted in my place point, then I could do that with multi-zone virtual limits and then trigger that with a switch or a sensor on the bridge, or maybe a mat or a light curtain in the area. So any way I can trigger that input, I could do that. I've got my output here, which would give me an output every time my e-stop is depressed. So if I were to e-stop the unit and I wanted to either have a confirmation that it was in e-stop mode, or I wanted to e-stop another external system like a line conveyor, I could do that with that output. And then I've got also my float mode output. So if I wanted to tell a PLC in a process every time I was in float mode, there was an input to an external PLC that wanted to know that, I could do that. So those are just some examples. You'll notice if I press the button to the right here, there is a wide variety of different features and functions that you can apply over and above the ones I just explained. And those are going to be available in your manual. You can look online, go to gorbel.com, and there's a detailed explanation of all of those in there if you're curious. Or again, you could call your Rhino Toolhouse salesperson, and they can go through that all with you and even do a live demo. So that is the I/O configuration. And that's kind of all I'm going to go through right now in the G3 and the user interface. That's the Smart Connect user interface. But I think we went through everything. We went through the intro. We talked about the difference between electric chain hoists and intelligent lifting devices. Went through some applications. Talked about flow mode, speed, precision. So I think that's a good overview of the demo. So at this point, I guess I'll turn this over for questions, and we can kind of get into some more dynamic discussion.
Okay, Mark, we have a couple of questions coming in.
Okay.
How many virtual limit sets are available is the first question.
Okay, that's a good one. So, I mentioned we have two models, Q2 and the iQ2. So the iQ2, I'll show I told you already, there's two inputs and two outputs. There, because of the availability of only two inputs, you've got your base set of limits, so which is no inputs on, and then if you activate either one of those other inputs, you can get additional two sets. So no inputs on would be one set. The second set, if you assigned virtual limits to set number or input number one, that would be a second set, and then input number two would be a third set. If you step up to your iQ, which gives you a lot more inputs and outputs, you get with the iQ unit, the iQ2, you get 8 inputs and outputs up at the actuator, or no, 8 inputs at the actuator and 4 outputs. And then on the handle, you have the ability to add 8 additional input-output points at the handle at the tooling. With all those different inputs, you can take advantage of all 4 additional virtual limit sets. So you get additional 3. So you get the base set with no inputs on, and then 3 other additional ones with the assignment of 3 additional inputs, giving you a total of 4 with the iQ. So that's the long answer. The short answer is 2 inputs, or a total of 3 with the Q2, and a total of 4 virtual limit sets with the iQ2.
So going with that same thought, Mark, one question is, what is the difference between the Q and the iQ?
Yep, and I kind of went through that right now, just now. So it's really the difference in the inputs and the outputs. So much more inputs and outputs available, both the actuator, which is if you needed to interact, say, with your line controller, I used that example before, you would want your physical location of your I/O to be in the actuator. The Q2, the base model Q2, does not have any actuator I/O. All the I/O is only resident at the handle. There's 2 inputs and 2 outputs. That's all that's all of this available on the Q2. When you step up to the iQ2, you have actuator I/O, 8 inputs, 4 outputs in the actuator, so you could festoon or wirelessly connect, or however you wanted to, and have those actual inputs, outputs at the actuator themselves.
How much room does this G-force take up versus a normal hoist?
Well, it's pretty comparable to a hoist. I would say, I don't know if you can pan the camera up. So this is the actuator. That's about the size of a typical actuator. That is the size of the actuator. And up here, you're looking at a hoist. Now this hoist over here is that's a 1-ton over here, single fall. And this is what do we got up here? So we got a 1/2-ton double fall here. So it's depending on what hoist you're comparing it to and what capacity, I'd say it's slightly larger than this double fall 1/2-ton. If you step this up to a single chain, single fall hoist, the one on the left here, that would get a little bit bigger, go up at least 1 body size, and be pretty comparable, I think, to what you would need with this G-force. So maybe a little bigger, but certainly a lot more packed into that unit for intelligence and features.
Please advise the cost for programming software.
There is no programming software. Actually, if we're referring to, I'm assuming you're talking about the Smart Connect user interface. The interesting thing is this actually comes standard with every unit. So this application here is actually running on the CPU. I'm actually visualizing and interacting with it with this device. So you download a simple VNC viewer program, and you can find free ones that are out there on the App Store, wherever you get your apps from. I'm using, there's actually Ultra VNC is a free one that I like to use. You can download, but that's all you need. So a VNC viewer, device, a Windows-based device, and a connection to the CPU, and you're up and running. There's no additional cost to do anything that I'm showing you here. That's all standard with both the Q unit and the iQ unit.
Is the 24-volt I/O fixed or programmable?
Okay, so we're talking about, I'm assuming you're talking about functionality of the inputs and the outputs. Those are programmable in the sense that we give you, as I showed before, if we click this button here, there is a list of pre-programmed functionality that you can actually assign to any input on the GeForce, and there's a separate list. You get a nice tight shot of that, Paul? Okay. So those are the inputs, and then for an output, there's a separate list, and that's that list right there. If there's anything that you need that's over and above that list, if you needed some twist on that existing functionality or something different than what we provide standard, we would just quote that separately as it's just engineering hours for programming. We could do a custom program, but we've been in this business since about 2000, year 2000, so we've really learned a lot. So the features and functions that we put in there that you have the ability to use right out of the box is going to cover, I'd say, 90% of the applications out there. So that is the hope. But again, if you need any kind of customization, we can certainly do that. Contact your Rhino Toolhouse sales rep. They would get the requirements, and we can quote a custom program that way. But outside of that, there is no additional charge for any of this interface or any of the standard features.
How does the GeForce durability compare to a standard electric chain hoist in steel manufacturing environments? And there's a parentheses, dust, impacts, etc. Yeah,
so the durability wise, it's very good. I'd say very comparable. There's always the debate between wire rope versus chain. What's better? What's more durable? The wire rope, actually, the advantage is, besides the being smoother, it's easier to inspect, and it's easier to see if it were to fail. We've actually had customers with chain hoists that have the perception that chain is a better, more rugged option. But if it's not inspected or maintained or lubricated, that is not the case. So wire rope, we feel, is the best choice for the GeForce intelligent lifting device with the speed and durability. As far as I'd say durability wise, as far as moving around and I guess that part of it, just moving around and interacting with the parts and picking things up and putting down, durability is equivalent. Maintenance is very, very easy on the GeForce. The one thing I would give the edge to an electric chain hoist is the environmental enclosure. So this is probably some of you, it's the NEMA rating of the actuator up here is probably like a NEMA 5. And on this one, we're talking more like a NEMA 3 to 4 on a standard chain hoist. So if you compare this to the chain hoist, the environmental protection of it is going to be a little bit better on the chain hoist. But with inside the servo motor and the inside of the unit is actually sealed completely. I think it's IP66, which would be like a NEMA 4 plus. So we've used them in steel plants. There would be a little bit more maintenance required in dusty environments with the GeForce over a chain hoist, though.
What is the max capacity for GeForce?
Maximum capacity for the GeForce is 1,320 pounds. So we go up to 4 models, up to 1,320 pounds, 165 opening point. That's the one we've been demoing here. Then your 330, your 660, and then your 1,320. And again, the EasyArm has all the same capacities except for the 1,320 pounds. The EasyArm goes to 660 pounds.
We are caught up on questions so far.
Okay. Is there anything else somebody would like to see? So we've got this live stream kind of demo thing. Normally, if you were here in the demo room, I'd let you come up here and you grab onto the unit and activate flow mode for yourself, and you kind of get to touch and feel a little bit for yourself. If there's anybody would like to see any other functions or like me to do something that I could perform in lieu of you actually getting your hands on it, do we have any of those kinds of requests?
All right. Well, Mark, we truly appreciate you giving us the behind-the-scenes look at Gorbel there. I did want to announce one thing. So, Max Kassler, you were the randomly selected winner of the toolkit that we announced there, that put on our flyer. So, Colin will get in touch with you and figure out how to get that to you. But from all of us here at Rhino Toolhouse, we truly appreciate all of you joining us today. Hopefully, you gained some insight. And as Mark said, your local Rhino Toolhouse rep should be able to get you all the information that you need, spec out an application, and integrate it with end tooling if required. So, again, appreciate it. And Steve, you will be sending out the flyer that Mark had showed earlier, the brochure. We'll send out that to everybody that was on the call today,
Yep.
or at least a link to it. So.
Yeah, and for those of you that might have joined us a little late and might have missed some of the demo, we will be putting this on YouTube and making sure that everybody has a link to it, just so you could share it with your team and review something earlier on if you missed it. But expect to see that over the next day or two.
Okay, thanks everybody.
Thank you. Have a great day.